constant cells. The conduction velocity is 0.3 up to 1 meter per second. 1 meter per second. Take a look at the figures here in this picture. The time that takes the impulse starts from the SA node, passes from internodal pathways, and reaches to AD node equals to 0.03 seconds. 0.03 seconds. In the AD node, we have three parts: nodal, atrial nodal, and nodal disc. 0.02 in upper and lower part, and 0.04 in the middle part. 0.03, 0.02, 0.04 means 0.09. We have a delay in AB node around 0.09 seconds. 0.09 plus 0.03 equals to 0.12. Then from AB node, the impulse passes to bifurcation through eastbound around 0.04. 0.12 plus 0.04 equals to 0.16 second. Impulse takes to start from the SA node to the bifurcation. This time gap, John. برگردوندم به قانون چه اکسیستری
مثلا کدوم اکسیستر با تهران بنا آمده از تهران آمده
This 0.16 second that takes the impulse starts from SA node till the bifurcation is called conduction time. Means the time gap that needs the impulse to reach from the atria to the ventricle. This is called conduction. It actually equals to the time gap from the beginning of the P wave till the beginning of the Q wave or R wave. If we do not have any Q wave in the electrocardiogram, which is called PR or PQ interval. PQ or PR interval equals to conduction time. The time that is needed for an impulse to reach from SA to the bifurcation. Then the impulse reaches to Purkinje fibers, which are among the fastest fibers we have, 4 meters per second. It takes 0.03 to depolarizes the whole entire endocardial surfaces of both ventricles. 0.03 plus 0.16 equals 0.196. 0.19 second. Then, from the endocardial surface to the pericardial one, we should add extra 0.03 or 0.04 in the right, in the left side, in the right side 0.02, because the left ventricular wall is thicker than the right one. So totally 0.22 up to 0.23 seconds it takes an impulse to start from the SA node till the last epicardial part of the both ventricles. The last epicardial part of both ventricles. The first part of the ventricle that is depolarized, the first part of the ventricle that is depolarized is somewhere in the interventricular part beneath the fibrous valve tissue from the left side to the right. The first part of the ventricle that is depolarized is the left side of the interventricular septum beneath the fibrous tissue. It depolarizes from the left to the right. Then both bundle branches will be depolarized, coming into the apex, goes up to the base of the heart. Did you get it? Depolarization starts from the SA node, internodal pathways, AV node, east bundle coming into the bundle branches. The first part in the ventricle that is depolarized is beneath the cardiac valves, the fibrous tissue, from the left to the right. Then both bundle branches will be depolarized, depolarizes endocardial surfaces of the both ventricles, going up to the base of the both.
Right now you're talking about the heart contraction.
We are talking about the
Heart
electrical events, not the mechanical events.
Electrical.
After the electrical events, we will have the mechanical events.
So is this like a nerves?
These are not the nerves, but they will act just like nerves. They are not muscles. This is the conductive system. They are very like the nervous system, the nerves.
Yes.
You see? But they are not nerves. They are a special excitatory conductors.
Yeah, which we have it in the heart because of the fibrous tissue in the heart.
In the morning, you got us the names of the sodium channel or potassium channels. These are not mentioned in the item. Do you have to memorize them?
To memorize what?
The potassium channels that you got us in the morning. All of them that are not mentioned in the item.
Because if you want to read a good pharmacology book, you should know the channels, all types of channels.
We don't have pharmacology in basic science.
It is also important for exam.
Yes. I will send some sample questions to you. Read the text and then I will send you sample questions to you. Learn them for.
Like in the first term, you send me.
I have studied the physiology chapter 8 by myself. But what you got is here, it is most of the things are different from the book.
It is mostly different.
Yes, because you got something briefly. It is not mentioned there.
No, if you mean at the first is something related to anatomy, we have to understand before.
No,
It's like introduction to physiology.
there was anatomy. I'm talking about physiology portion.
You mean what I mentioned in the classroom
Yes.
is more brief than what is mentioned in the document? Are you sure?
Yes,
I'm sure.
I
Which
studied
part?
each and every line.
Which one?
Detail.
Which one?
Actually, I mean detail. It is more detail.
Mine is more.
Detail.
Yes. A good teacher should explain more than the book.
Yes, it is only for the sake of understanding or for the exam. I want to know.
You see, in order to better understand the text, I should explain more. But for the final exam, except that action potential, except that part that are discussed, action potential part, which is taken from them physiology book, the rest is
Say hi to camera. You
see, from that curves I have discussed, quite a few questions can be taken out. That is why I explained it. The curves have not been discussed in
أكثر شوي إن شاء الله بعدين إن شاء الله ما أجيب لك حاجة فايدة.
You have passed eccentric concentric contraction in a skeletal muscle. It doesn't mention in the art physiology chapter. What you should know, you should bring those knowledge from the skeleton and even the smooth muscle. Bring it to the art physiology chapter and combine them, mix them. You should also read between the lines, intervene when you read, because you're medical students. Now, listen. So, we have SA node, AD node, Purkinje fibers. How much does it take an impulse start from the SA node to reach all the epicardial surface? 0.22 up to 0.23 seconds. The fastest Purkinje fibers, the slowest AD node cells. We have two types of cells in AD node. P cells and T cells. P cells are round, T cells
Elongated.
elongated, exactly. They have very few actin and myosin, very few. Now, up to now, we have covered the 10th chapter.
9th chapter.
We have covered the 9th and 10th. 10th up to now. I have described excitatory system. Take a look. Yes.
So the ninth,
Now let me start with electrocardiography.
ECG. The 9th chapter is harder than the 10th?
No.
They're all equally difficult.
You see, the most intricate part was action potential. I have discussed it in cell physiology. Again, I repeat it, and the last part which I want to cover here in your classroom is the vectorial analysis. Because if you read it, you cannot understand it, unfortunately. It is rather difficult to learn the vectorial analysis.
You just explain everything.
Yes, I have explained this part.
Oh my God. I
You
think
sure? No.
I think that is
No,
harder
no.
than.
I will explain one, Stokes-Adams syndrome, and then electrocardiography. Listen to me.
Could you please repeat that?
Which part?
This.
These figures, you see,
Yeah.
0.03, 0.02, 0.02, 0.04, plus 0.03, 0.12, add 0.04, 0.16, add 0.03, 0.19, add 0.03 equals to 0.22.
Do we have to memorize this? Do we have to
It
memorize
is better to remind.
Doctor, so we
I
have.
will not ask you in the final exam, but if you want to learn the sequence of time in electrocardiography, you should know them.
Where I can find it?
Is it
In the guide, where I can find
Which
it?
one?
This.
Yes.
Just this figure from this chapter?
Yes.
but isn't it enough to know that the impulse first from SA node, then to AV node, then through the AV bundle, and then through the Purkinje fibers?
Yes. The sequence of activation is what you said. SA, internodal pathway, AV, his bundle, bifurcation, left bundle branch, right bundle branch, the whole endocardium and epicardium.
That's what's important, right?
Yes.
So I will leave all this chapter and say just this figure, right?
No, I have I have discussed the sympathetic and parasympathetic in the previous session.
Yeah.
Now listen. Why, other than SA node can initiate automaticity of the heart, there are other points and the structures in the atria and the ventricle to initiate different stages?
I think is that they all initiate, but the one initiated by the SA node is more powerful, and so it is
No
the one.
powerful, it is faster than others.
Yes, so it is the one that excites the cells.
It is faster. Because the number of beats in a minute that can produce in the SA node is around 60 up to 100 in normal situation, beats per minute. Somewhere in the AD node can also initiate beat producing. But the number of beats that can be produced in the AD node is much less than 40 up to 60. Even in Purkinje fibers, we can produce beat initiating. But the rate would be very slow, 15 up to 40. If, for example, in rare situation, the SA node stops sending impulses, then AD node can send. But remember that the direction of impulse is the pass is from up to down.
Always.
We do not just in one direction. But in very rare situation, the impulse can pass in both in opposite direction and activates the atria from down to up.
Isn't there more than 9 or 15 places where conduction
Anywhere.
Anywhere in the heart?
Anywhere in the heart, even in the atrial muscle itself or ventricular muscle itself. In rare situation, especially during hypoxia, can send signals and activates the heart. For example, suppose that the SA node stop sending impulses. Then somewhere else in the AD or in the ventricle, they start sending signals. But since the other places are overridden by the SA node, there is a time lapse between stopping the SA node and starting other focuses in the heart. During the first 4 seconds, when the heart stops beating, no blood goes into the brain and the person will lose his consciousness until 20 seconds, 15 seconds later, 5 to 20 seconds later, other places than SA nodes start sending signals. During this time lapse, the person should lose his consciousness. This is called a Stokes-Adams syndrome. And then somewhere else in the atria or the ventricle escapes from this overridden phenomenon and starts sending signals. This is called a Stokes-Adams syndrome. This chapter is over. Now listen how I use these figures to explain electrocardiogram to you. Carefully listen to them.
You should.
Is it possible to explain vectorial analysis first?
Definitely. No. First you should know the electrocardiogram. First you should know. Listen to me carefully. It is very easy to